Hey, I'm going to talk about the Pythagorean theorem here a little bit, but not just the Pythagorean theorem, the converse of the Pythagorean theorem. And the converse of the Pythagorean theorem sounds kind of like some complicated idea, but it's really not. What it means is that if you can argue that when we have a right triangle, so the Pythagorean theorem says, if we have a right triangle, it says, if this is a right triangle, then a squared plus b squared equals c squared. So if you have, or when you have a right triangle, it's been established it's a right triangle, or it's given, or they're telling you that's a right triangle, then a squared plus b squared equals c squared. And that's what the last couple of assignments and lessons and everything were about. The converse says this. So in this idea, we start here. If we have a right triangle, then this. So if this, then this is also true. Well, the converse of it is kind of like a reverse or backwards way of looking at it. If a squared plus b squared equals c squared, then this is a right triangle. That's all the converse is the Pythagorean theorem states that when you have a right triangle, this is true. But the converse says, well, if you have three sides of a triangle and this happens to be true, then you're looking at a right triangle. So if you just have three sides of a triangle and it ends up being a squared plus b squared equals c squared, then it's a right triangle. If it doesn't equal, then it's not. Okay, so let's look at a couple of examples of that. Now let's say that the first example that they have in the book is that a equals 9, b equals 40, and c equals 41. Well, this is a leg, and this is my hypotenuse. So really what they're saying is if a squared plus b squared equals c squared, then these three sides to this triangle, if a squared plus b squared equals c squared is true, then 90, 40, 41 makes a right triangle. So let's put 9 in here. 9 squared plus 40 squared equals 41 squared. 9 squared is 81. 40 squared is 1600. And 41 squared is 16. Whoa, that's not 16, bro. 1681. So what does 1600 plus 81 equal? 1681 equals 1681. When is 1681 equal to 1681? All the time. This is true. So a squared plus b squared equals c squared. This is a right triangle. And that's how you prove it. Second example in the book looks like this. 8, 10, and 12. So A is 8, B is 10, and C is 12. So if a squared plus b squared equals c squared, then it's a right triangle. So a squared would be 8 squared, b squared would be 10 squared, c squared would be 12 squared, and 8 squared is 64, 10 squared is 100, and 12 squared is 144. 100 plus 64 is 164, and 144. When is 164 equal to 144? It's not. That's right. So this does not make a right triangle. Now, does it make a triangle? Yes, because if you had a something like this that was 8, 10, and 12, you could make a triangle with those three numbers. You can't make a triangle with all lengths. There are some that you cannot make triangles with. For instance, if we made that a 20, these points would be so far away that the 8 and 10 couldn't reach them, because the farthest that these 2 points could be would be 18 away. And if you put the third side 20, it's too long to even make a triangle. But this makes a triangle, it's just not a right triangle. And that's what we're looking for. Because when we know we have a right triangle, then we can solve other problems later that are more complicated. Having established the right triangle helps us out with those problems, right? So this is just not a right triangle. It's still a triangle, but it's not right, okay? And that's what, again, what the converse is all about. If we want to know something about the triangle and we can prove that it's a right triangle, I already know what's going on. Well, and for instance of that, one thing I know, in every single right triangle, I know that this triangle, or this angle over here, and this angle total to be 90 degrees. So I know that angle A and angle B equal the angles that are opposite this. This would be capital A over here, and this would be capital B here. If this is a right angle, 90 degrees of my 120 total, or 180, sorry, getting ahead of myself, 90 degrees of my 180 total has been taken care of right here. So if this is 90, there can only be 90 left between the other two. And that helps us solve problems later with trigonometric ratios like sine, cosine, and tangent. Those kinds of things work with angles that are between 0 and 90 degrees. So these two are complementary of each other. That's what co in cosine stands for. Sine and then cosine, or complementary sine. So these two are complementary of each other. If I know that this is a right angle, those two must be 90. If we're looking at the one before, 8, 10, and 12, I don't know that this is a right angle. So I have a right triangle. So I have no idea how much is in each one of those angles. I do know that the three of them total to 180. However, I don't know which one has which value. Okay? So the converse helps me here knowing I don't have a right angle. Over here, I have a right angle, right? So I'm glad I thought of that. So the first thing that happens here in the homework is they give us 3 lines, and they ask us if they are, if it is a right triangle. So let's look at, let's just look at one of them, 7, 10, and 13. What if they just give us, and this is what I wanted to talk about, is if they don't tell us that A is this, B is this, and C is this, what if they just say, hey, we've got 7, 10, and 13. Figure this out. Is that a right triangle? Okay, now, we know we have 3 sides of the triangle. One of the things that we know about every single right triangle is that the C, or the hypotenuse, is always the longest line. So which one of these is longest? The 13. This one is C. Now, some of you are not going to be comfortable with this. That would have made you uncomfortable anyway. Some of you are not going to be comfortable with this at first. But it doesn't matter which one of these is A and which one of them is B. They're both on the same side of the equation. They're both squared, and then it's added together. It doesn't matter if I take 49 and add it to 100, it's going to be 149. Or if I take 100 and add it to 49, it's going to be 149. It does not matter which way I set this up. It doesn't matter. This is my C. A could be here, or B could be here. Or A could be here, B is over here. Either way works. It does not matter. So I'm just going to call this A, and this b, whatever. So if a squared plus b squared equals c squared, this is a right triangle. So 7 squared plus 10 squared equals 13 squared. And 13, let's see, 7 squared is 4 9er. 100 squared is 100. Yes, there was a 9er in there, and yes, we were on walkie-talkies. 13 squared is 169. 49 plus 100, 149, 69. When does 149 equal 169? They don't. So this is never true. Since this is never true, this isn't true. The a squared plus b squared equals c squared isn't true. And if this isn't true, we don't have a right triangle. We do not have a right triangle. Now, does this make a triangle? Yes. It's just not a right triangle, right? I'm looking at the homework. Doesn't look like anything else could be difficult in there for you. I don't think we even have an isosceles right triangle, which would make things difficult. The next lesson is about the distance formula, which is a little more difficult, but this one should be a piece of cake. Pythagorean theorem. If this is a right triangle, a squared plus b squared equals c squared. The converse of the Pythagorean theorem. If a squared plus b squared equals c squared, then you have a right triangle. So it's the backward argument. All right? Have fun. Stay cool.